Have you ever looked up at the night sky and wondered what lies at the very heart of our Milky Way galaxy? It's a place of unimaginable power, mystery, and maybe even a threat to our very existence. For centuries, we saw the Milky Way as a serene, sparkling river of stars. But modern astronomy has revealed a much more turbulent and violent reality. At the center of our galaxy, some 26,000 light years away, lurks a monster, a supermassive black hole named Sagittarius A. It's 4 million times more massive than our Sun, and it's not just sitting there quietly. It's an engine of cosmic chaos. Imagine a region so dense with stars that if you were on a planet there, the night sky would be a constant blazing inferno of light. This is the galactic core. It's a place where stars are born and die at a frantic pace, and where gravitational forces twist and warp the very fabric of space-time. But the real star of the show, or rather the anti-star, is Sagittarius A. Like all black holes, it has an insatiable appetite, pulling in gas, dust, and even entire stars. As this material spirals into the abyss, it doesn't go gently. It gets superheated to millions of degrees, forming a swirling, chaotic disk of plasma. This accretion disk glows with more intensity than a trillion suns, unleashing colossal jets of energy and particles. These are the galactic waves we're here to talk about. They're not like waves in the ocean. These are tidal waves of high-energy radiation, gamma rays, X-rays, and powerful winds of subatomic particles, all blasting out from the galactic center at nearly the speed of light. Scientists call these phenomena galactic outflows or Fermi bubbles, gigantic structures extending tens of thousands of light years above and below our galaxy's plane. They're like the ghostly exhaust fumes of our galaxy's central engine, evidence of cataclysmic eruptions that happened millions of years ago. We know our galaxy's black hole has been far more active in the past. So the big question is, what would happen if one of these galactic particle storms were aimed directly at us? Geological and fossil records on Earth show strange, cyclical patterns of mass extinctions. Life on our planet seems to flourish, then suddenly it's nearly wiped out. Events like the Ordovician-Silurian extinction or the late Devonian extinction have long puzzled scientists. While asteroid impacts are a popular explanation, they don't account for all of them. Some researchers are now looking to the stars for an answer, specifically to the heart of our own galaxy. The theory is that every few tens of millions of years, the Milky Way's core flares up, sending a wave of cosmic destruction rippling through the galactic disk. If Earth happened to be in its path, the consequences would be catastrophic. Let's paint a picture of what that might look like. The first sign wouldn't be a giant explosion in the sky. It would be invisible. A wall of high-energy cosmic rays would wash over our solar system. The first line of defense is our planet's magnetic field, the magnetosphere. It's our planetary shield, constantly deflecting charged particles from the sun. But a galactic wave would be like a solar storm on steroids. It could compress and overwhelm our magnetosphere, allowing deadly radiation to pour into our upper atmosphere. As this radiation bombards the air, it would shred molecules, particularly ozone. Our ozone layer, which protects us from the sun's harmful ultraviolet radiation, would be severely depleted. Without it, UV levels on the surface would skyrocket. This would be devastating for life. Plants, the foundation of most ecosystems, would struggle to perform photosynthesis. Plankton in the oceans, responsible for producing much of our oxygen, would die off. For humans and animals, the risk of skin cancer and cataracts would increase dramatically, but the more immediate danger would be the collapse of the food chain. The climate would also be thrown into chaos. The energized particles hitting the atmosphere could create a vast number of cloud condensation nuclei. This might lead to a period of global cooling, potentially triggering an ice age, as more sunlight is reflected back into space. The beautiful auroras we see at the poles would become a global phenomenon, a deadly light show signaling the breakdown of our atmospheric defenses. Our modern technological civilization would be particularly vulnerable. The intense electromagnetic pulse from the wave would fry satellites in orbit, crippling global communication. GPS navigation, and weather forecasting. Power grids on the ground could suffer massive surges, leading to continent-wide blackouts that could last for months or even years. We'd be thrown back into a pre-industrial dark age, but with a poisoned atmosphere. So, could humanity survive such an event? The answer is, maybe. It would be the greatest challenge our species has ever faced. Survival would depend on our ability to prepare. We would need to build underground or underwater habitats shielded from the radiation. We'd have to develop new forms of agriculture that could thrive in low-light, high UV environments, perhaps in vast subterranean farms. Our reliance on fragile global supply chains and satellite technology would be our undoing. A surviving society would have to be decentralized and resilient. But this isn't just science fiction. Astronomers are actively searching for signs of these events. How do you even detect something like this coming? We can see the galactic core directly in visible light because of all the intervening dust and gas. But we can see it in other wavelengths like radio waves, infrared, and especially high-energy X-rays and gamma rays. Telescopes like the Chandra X-ray Observatory and the Fermi Gamma Ray Space Telescope act as our eyes, peering through the cosmic smog to monitor Sagittarius A. They watch for flickers and flares, sudden increases in brightness that signal the black hole is swallowing something big. Just a few years ago, astronomers watched a gas cloud called G2 get dangerously close to our black hole. The scientific community was on the edge of its seat, expecting cosmic fireworks. While G2 mostly survived its close encounter, it was a stark reminder of the dynamic and violent nature of the galactic center. By studying the remnants of past eruptions, like the enormous Fermi bubbles, scientists can piece together the history of our galaxy's activity. It's like cosmic archaeology. They analyze the chemical composition and energy levels within these bubbles to understand the power and frequency of past outbursts. This data helps them build models to predict when the next big one might happen. The good news is that right now, Sagittarius A seems to be relatively quiet. It's in a slumbering phase. The massive outbursts that created the Fermi bubbles happened millions of years ago, and the radiation from them has long since passed us by. Based on current models, we don't expect another major galactic wave event for at least a few million years, so you can sleep soundly tonight. Our planet is not in immediate danger from its own galaxy. But this research is about more than just predicting a distant doomsday. It helps us understand our place in the cosmos. It reveals the powerful forces that have shaped our galaxy, our solar system, and even the evolution of life on Earth. The universe is not a quiet, gentle place. It's a dynamic, sometimes violent, and awe-inspiring arena of creation and destruction. The heart of our own Milky Way is a perfect example of this cosmic duality. It's a source of immense gravitational power that holds our galaxy together. And yet, it also has the potential to unleash waves of destruction. By studying it, we learn not just about the threats that may lie in our distant future, but also about the incredible resilience of life to have survived on this tiny blue dot for so long, navigating a cosmic ocean full of unseen dangers. The journey to understand these galactic waves is a journey to understand our own story, written in the stars. Thank you for joining us on this exploration to the heart of the Milky Way. If you found this journey as fascinating as we did, don't forget to like this video and subscribe to our channel for more deep dives into the mysteries of our universe. What other cosmic phenomena do you want to learn about? Let us know in the comments below. See you next time.